Hello, I'm Joseph Lumba. I'm here this morning to talk about a method which produces energy from gastric juices. Gastroscopy is a procedure where doctors stick a tube down the patient's throat esophagus up to the stomach. Basically, the aim is to gather information that cannot be collected from outside the body. Since this method introduces a huge discomfort to the patient, swallowable pills, whose job is to collect data from the digestive tract, were invented. This is efficient except for two main problems. First, these can get stuck anywhere along the digestive tract, which requires surgery to remove the pill. Second, you have the issue of the power source. Chemical batteries cannot simply be ingested. Furthermore, once the battery dies out, you cannot just charge it from the outside. That's why these guys from MIT, Traverso and co-workers, started to develop a biodegradable sensor pill which can be powered by something that is already inherent to our digestive system, hydrochloric acid. This study tackles two areas with regards to innovation. First, the focus of the study is the use of stomach acid to power the sensor. Second is the shift from the conventional sensor components to biodegradable, biocompatible circuit elements. The pill's design involves the concept of a galvanic cell. Electrical energy is harnessed from the movement of electrons in a redox reaction. The power source can be described by the figure shown. Once the pill is in the stomach, digestive fluids enter the pill and act as the electrolyte. Notice that they are using metals which are prominent for their dietary value, at the same time cheap. They placed this in the digestive tract of a pig, and the cell was reported to produce an average power of 0.23 microwatts of power for 6 days, enough to transmit data to a receiver outside the body. To illustrate the utility of the electric energy obtained, they created a system powered entirely by the zinc copper cell, which includes temperature measurements and wireless transmission to a database situated 2 meters away. The following plots were also recorded. The cell charges until a storage capacitor has enough power to send temperature data. The first plot shows the charging of electrical energy, then the transmission once the peak is reached. The second plot shows the temperature readings gathered by the sensor. The disconnected regions represent the periods when the electrical power is not enough to send data. To further show the viability of the energy produced, they used the electricity to mimic controlled drug release. Power from the cell was used to corrode gold film and release guest compounds, in this case a blue dye. The gold film, which is otherwise inert in gastric environment, formed water-soluble gold complexes as the potential was increased. Several patents which date back to the early years of this decade have already been filed for the use of ingestible sensory pills. The field has already been around for a while, an evolution from conjectures to the actual fabrication of the pill. What's interesting in patent wars is you can build on the idea of others, then claim the development that you have done. The second patent shown lays claim to the in vivo device similar to a sensory pill. And finally, last June, one of the main authors of the paper, Swiston along with other co-workers, filed for a patent about ingestible devices. Innovation in this field entails building up on the finding of others. Future developments involved in this study can be divided into two branches. First, improvements on the device itself. This device can still do processes aside from measurement of temperature. If it can store enough energy to power more complex attachments, for instance cameras, it would be able to do more complicated work. The pill can also be programmed to collect continuous strings of data, then send them after a certain amount of time. The development then becomes focused on power management. Other materials can still be used to build a galvanic cell, for example minerals and vitamins, which can undergo redox reactions. There are polymers used in medicine which can act as casings and can degrade inside the body. Second, if a self-powered pill can be placed inside the digestive tract, why can't it be extended to the other systems of the body? The study discussed controlled drug release. Delivery would be more efficient if the pill can tap to the circulatory system.